Howdy, everybody. We're here on day 15 for Advent to Code. I just wanted to talk about my solution and kind of do an analysis of the problems. And this day kind of felt like a blast from the past to data structure and algorithm courses. So if you've done some of those courses before, that's what this feels like. It means the problem wasn't particularly hard if you're familiar with hashing and hash maps and stuff like that, or you were able to like find a way to implement those in your own language that already had them. So anyway, I had a lot of fun with it overall, but I just wanted to say before I get too far into it, thanks again. I'm getting a lot of positive feedback. I really appreciate that. It's cool to know that you guys are getting stuff out of it, and hopefully that keeps happening. Obviously, we got 10 days left of Advent to Code, and I want to try and finish all those. We'll see how the days go, especially as the holiday gets closer. But I do plan to try and finish them, and after that, then we got a whole wide open field of things that we can talk about. Maybe not on a daily basis, but definitely on a more regular basis, where we can say, hey, here's an algorithm that maybe we can talk about in more details. Or I know people have asked about how I do my programming and stuff like that. So if you have ideas for things you'd like to talk about after we get done with Advent to Code, just send them my way in the comments, and I'll be happy to entertain in those ways. So what is day 15 about? Again, it's more of an algorithm data structure type thing. There wasn't really any trick to it. It's you basically just, can you follow instructions? And the instructions for the first part was, can you implement a hash? And they actually give you the hashing algorithm that they want you to use, right? Again, if you've taken a course on hash maps and data structures, you know that picking a good hash is important. In this case, we actually don't care about the hash because they've told us what the hash is. And so the idea is, given any string, you iterate through all the characters, and you start your hash at a value of 0. And the steps you take are, you add the ASCII code, the equivalent integer value for each character, and then you add that to your current hash value. You multiply your hash value by 17, and then you do a modulus operator 256, which would bring, if you were outside of the 256, it would bring you into the 256 range. And we'll talk about that in a minute, right? So if you think about the size of your hash map, it's going to be 256, places, boxes, or whatever, right? Buckets, I think, is what they call it, in at least what I remember in my data structure class. So once you've done that, you can now you can determine the hash of any string, right? And now it's going to ask you to test your hash value. So it's going to give you a string like this, and it wants you to split the string by commas, and you're going to take each of these pieces and calculate that hash. And then it wants you to do the sum of those, right? These values look a little weird. They have like CM equals 2, QP minus. This will make more sense in part 2. But for now, you're just worried about take the whole string and run hash, the hash program on it, get your value, do that for each of them, and add all those to get to your solution. So again, that's not too difficult. If you look at my solution, I'm literally doing that, right? Like, here's my hash algorithm. I just start at 0 for each of the characters. I'm going to add that to my current hash value, multiply by 17, and then do a modulus operator. The one thing to note here that I just want to talk about really briefly is that I'm using a usize here, and depending on the language you use, this may or may not be pertinent, right? I think in Python it defaults to an int, and so you don't ever have to worry about overflow, but it is something to like keep in mind, right? In Rust, it will actually it will prevent you from doing an overflow, right? So if I were to, for example, because they're bytes or characters, if I did this as a U8, And I'll have to do some changes here like this. Notice I get an error, right? So if I try and run this, it says, hey, the literal 256 is not a U8. What are you trying to do? That's not going to work. And this is just, again, this is Rust, the Rust compiler trying to warn you. The reason being is, and like maybe I can try, like if I were to comment out this line, for example, like what is it trying to warn me about? If I try and run my program, notice I get a stack trace. Again, this is just Rust doing the stack trace, right? I'll show you an example in C where it actually works. It's blowing up with an attempt to multiply with overflow on line 142, right? So one of my operations when I multiplied by 17 brought me outside of the U8 size. And again, for most languages, you probably won't run into this problem. And obviously I used a U size, which was definitely going to fit. Right. So this fits no problem. The work I'm doing is definitely going to fit into a U size. If you're using another language though, like here's a C example, again, if you're just using an int in C, you're probably not going to deal with this issue because you're not overflowing. But here, if I purposefully use a U8, actually, let's cat that again because I think it looks more like this. If you cat a U8, or if you're using a U8, in C, it won't do a stack trace, right? Notice I'm using a U8, but I still do modulus 256. If I try and run this, it runs just happily. But notice what if I try and do this in a right-sized variable, notice that it's giving you values like that are way out of the range. And that's because C doing operations out with overflow is technically undefined. So you actually don't know what the result is. But at least for my compiler, it defaults to what's called wrapping. So if you're at 255 and you add 1, which would overflow, instead of throwing an error like Rust does, it will just move it to 0, the next value, right? And I'm sure many of you are aware, but the CPU, at least modern CPUs, are smart enough to tell you this, right? Like if you go down into the actual code and you're writing like machine code or assembly, it will tell you, like when you do an addition, you can check to see if it caused an overflow. And I don't know if Rust does that, if Rust is using the CPU or not. I haven't looked into the internals of how it's checking for overflow. But it will check for you, right? In the case of C, the behavior is like quote unquote undefined. In my case, everything is modulus 256, so it just magically works. That's what we're interested in that wrapping, right? The multiply, add, and modulus things all work with wrapping just fine, and so that's why it happens to work. Excuse me, but most languages, again, you won't run into this problem. You'll probably just use an int, and so it won't be a big deal. In my case, right, I used like a U size, so it wasn't a big deal. But to be honest, there's not a lot to talk about for part 1, and so I thought I'd just go in there. One of the things I do like about Rust is it will catch these for you. In this case, doing the overflow was actually okay. Again, like I said, in C, you'll actually get the right answer because it's doing that wrapping. But there might be other cases where that's not okay, right? And you want to know when you've gone out of bounds because you're going to produce incorrect results. And so it's nice that Rust will tell you that, right? And so it will say, hey, what you're doing here is probably not a good idea. Excuse me, I don't know why I'm yawning. Sorry about that. Okay, so that's part 1, right? And you can see my solution to part 1 is pretty simple. I literally am just reading the input, splitting it by commas, calling my hash function on each of the values, and then summing them up, just like the problem. Easy enough, not a big deal, right? Part 2 is the high level way of thinking about it is, now you have a hash algorithm. I want you to create a hash map and track values. And again, if you've taken like a data structure course, like what you're doing here is essentially what you do if you were creating your own version of a hash map, right? And it describes it in details here. Notice what changes is now you're actually only hashing on this part of it. Each of these comma separated sections right here is actually a label and then a command. And the minus command means remove. It's saying remove QP from a box. And CM equals 2 is saying add CM to its correct box and give it a focal length of 2. The way to describe it, why I'm using focal length, is you have all these boxes and you're trying to shove lenses in the boxes, but you're trying to do them in like the correct order based on your hash values. And so this is the label and this is the focal length. So you're going to pull a lens with focal length of 2 and you're going to put it in the box that CM hashes to, right? Or RN hashes, whatever. I think RN hashes to 0. And is that right? Let me look down here. Yeah, RN hashes to 0. And so it wants you to add a lens of 1 in there. And then it just asks you to do some operations for the adds and removes, right? There are some special cases. It says like, hey, if RN is already in there and you do an add, instead of like adding it to the list, I want you to overwrite the existing value, right? And when you call a remove QP minus, you want to remove QP from it if it exists, but you want to keep all of the rest of them in the same order. And that's essentially what's happening here. So if you think about what you're going to do, you're going to create your own little hash map, and you're going to be given a label and a lens value, and you're going to do a hash on the label and figure out which box it should go in, which of the 256 boxes it should go in, and then you're going to stick that lens in there, either at the end if it's new, or replace an existing one if it's already there, if the label's already there, or remove it if it asks you to remove one of them. And so it goes through the operations with you, right? So given this string right here, you can see like the first thing it does, it's going to insert RN into box 0 with a focal lens length of 1. Because you do RN equals 1, that's an add operation, and RN hashes to 0. CM minus, there's no CM, and so it can't do anything. QP add 3, QP hashes to box 1, and so you just do an add here. CM hashes to box 0, and so you add CM2 here. QP minus, you're now removing this from box 1. Okay. I hope that makes sense of what you're doing. And the way to think about this, if you've done algorithm courses before, this is not much different than like the way they're actually implemented in real life is not always this way, but I kind of drew this out so I could explain it. Usually the way a hash thing works is you have these boxes, right? I think they call them buckets in other, at least in my algorithms course they did. Maybe if they called them something else for you, that's fine. But so you have all these buckets, and each bucket is actually a linked list. And why is that? It's because hashing obviously is taking a potential for a large set of things and creating it in a smaller. So you can get collisions where, like specifically here, RN and CM both hash to bucket 0, right? These labels both get placed in bucket 0. And so how do you track that in your data structure course? You'd usually create a linked list, right? And so if you imagine the case where you're removing QP3 here, you would or so the operation that you're being asked to do is QP minus, right? You hash QP, and that maps to 1. And now you just need to go do your operations, right? You look for QP, and you find that label here, and so you know you have to remove that. And so now box 1 just maps to the to an empty list, right? And that's how it is. If you're doing an add, in this case, it's not a sorted add, right? So you don't have to, you're just going to add it to the end of it. So when you're adding, I don't know, some value that would hash up here, you're just going to do the linked list insert operation, right? You're going to put it on the end here to your new value. Okay, that was a lot of explaining, but there actually isn't. I mean, if you're familiar with hash maps, maybe you were able to get it to work in your own language. You know, you just said, oh, I'm just going to do hashes and track all the duplicates in there and remove them. I kind of wanted to try and do this myself so you can see how it would look in Rust. Obviously, the linked list thing is a little tough. There is a linked list in Rust in the standard collections, but it doesn't implement remove. That's like a nightly thing. So I kind of waffled between using a linked list and not using it. I ended up just using a vector for my solution because it has similar operations, right? You can just do a pushback. You know, you can iter try and find. If you don't find it, you do a pushback. Then you can do a, if you're doing a delete, you can do a find and remove the thing, right? So what does that look like? I actually changed it around, right? Because part 1 was literally just implement this hash function, and then, you know, do that for each of your pieces. In this case, I actually created a steps structure, and then a boxes structure that does the actual hashing. So let's kind of look at that code and see what happens. Before, remember, you were just hashing the whole string. Now you're not actually hashing the whole string. So I did end up using nom to parse this for me. It felt easy enough to parse this way, right? You imagine for your input, it's going to look like this. So let me grab it really quick so you can kind of walk through it. The idea is you're going to get this chunk right here, rn equals 1. And so what do you want to pull out first? It said the labels are always alphabetic characters, right? Just letters. So the label is just an alpha 1. And then you're either going to get an equals and a number, or you're going to get a minus, right? So the number is going to be the focal length, and that indicates that you should add. And the minus is going to be remove. So I actually created an operation enum for that, right? Either remove or add this focal length right here, the U size. And in nom, I think, you know, we tried to work through those in earlier examples. The way that you do that is an alt, meaning it's going to be one of these. And the one of those is a minus for operation remove. The other is an equals with some number of digits, and you call this function. This preceded function is kind of a cool way of saying you're going to get this preceded by this, and then once you figure out what the preceded says, once you figure out this, then you can map this to that part of it, and that's just add with an s parse unwrap. So that gets you the operation, this gets you the label, and then your parse function is as simple as enough as just calling new on that label and operation. Got it? So parse all, what do I do? Well, it's just a comma separated list. So in nom, I can use separated list to get myself a vec of steps. So now I have a bunch of steps. What do I want to be able to do with each step? Well, obviously I want to hash it. And in this case, remember, this is just the same hash algorithm from part 1. But instead of doing it on an input string, I'm now just doing it on the label. Remember, I'm not interested for part 2. I'm not interested in the rest of it. I'm just interested in the label. Okay, and then obviously I want to store a lens with a label and a focal length. So I added this here. If you're not familiar with Rust, I'm just using a lot of lifetime qualifiers here, and this is just to simplify so I don't have to, you could use an actual string, but I'm just saying I can reuse the input so I don't have to like recreate all that stuff. That's what those, you see all these quote A's here. That's just the lifetime qualifier if you're new to Rust. Feel free to look up lifetimes if it looks foreign to you. It's another cool way, like we were talking about integer overflow, for in Rust to help you deal with ownership, right? Is like, hey, do I own this value? Can I use it? And how can I use it? And so that's what that's doing. So now I need a lens to store in my box, right? If you remember from the problem, we want to actually store the label and the focal length, these two values. And so that's all the lens is, right? We have a label and we have a focal length. So what are my boxes? It's just a vec of lenses, right? We know the box's size is always going to be 256. So when we initialize the boxes, we create 256 empty buckets is the way to think about it, right? And then I have these perform step functions that kind of aid us in processing the each of the steps, right? So given a list of steps, I can call perform step on each of them, and that will do the job of inserting, adding, removing, those type of things. And the perform step, again, there's only two operations, so this is actually not that hard to do. What do? You could potentially like combine these, because I don't know why you'd ever perform a step and not do all of them, but this is just what I was doing as I was thinking through the code logically, right? Well, what I was thinking is like, okay, what do I do? Well, I perform a series for each of the steps. I want to perform some step, and then what is that perform step? Well, we either are going to do a remove, and I created helper functions from this where I call self remove, and I give it the hash and the label, right? So the hash will tell me what box I should be in, and the label will tell me what value I should be trying to remove. The other operation is add for the focal length, and what do I need for add? I also need the hash, the label, and the focal length. I suppose I could have made this into a lens right here at this point. That might have been more interesting. But again, I need the hash to figure out what box I should put it in. And then I need the label and focal length to create the lens that I'm going to put into my box. So what does that add operation look like? Basically, I'm going to create a new lens, and I'm going to look to see if it already exists, right? Do I already have it? Interesting. I could have put this down here, I think. Like that. That probably still works. First, I want to see if it already exists, right? That's what it told us in the thing here. It said, hey, if it's already in the box, you just replace the old lens with the new lens, right? So the label doesn't change. You're just changing the focal length. And so that's what this for loop does, is going to look through all of the items in the box, and it's going to check and see if their labels are equal. And if it is, it's going to then update the focal length, right? And once we've found it, we can return it. We know there's only ever one, so we can return it. So if you think about it, like if we're down here and the operation is PC equals 9, PC will map to, it hashes to 3, right? Like that. So we know we're working in box 3, and we're just going to iterate over each of those items and see, hey, is it in here? No. Is it in here? No. Is it in here? Yes. So instead of like, doing any weird stuff with it, we know we can just change the 6 to a 9 and we're done. Otherwise, if we don't find it, then we want to just add the new label. And for a vector, that's just a push, right? So again, if you're working in linked list land, you'd probably do something similar. Instead of calling like an iter mute, I think the linked list in Rust still uses iter, But you could imagine just calling, hey, what's the next node, until you either reach the end or find the node that has the same label, update it. And if you don't, you just put it at the end of it, right? You presumably have some kind of pointer to your tail in your list, and that's where you'd add your new lens to that. So how does remove work? Again, you're doing the similar for loop, where you're going to say, hey, I want to look at all of the elements in my box, the box that maps to my hash. And if I ever find the label, I can just call remove on it and be done with it, right? This is, again, is a vector thing. Removing I removes the ith element from the hash. And I don't have to worry about the, how the vec is doing that, how it's like squashing it or whatever, right? I just call remove and it solves that. If you are using a linked list, right? So imagine here the operation, instead of PC equals 9, it's PC minus, right? Again, the hash of PC maps to 3, so you're in box 3, and now you're going to do a remove, so you're just going to look through them. Is this one a PC? Is this one a PC? No. Is this one a PC? Yes. So now I have to do a remove operation. And what is that involved is you're taking the tail of this one, which is here, and linking it to this one. Or I guess that's in a doubly linked list. In the singly linked list, you're now taking the head of this one, which is this one, and mapping it to the tail of this one. And then in a doubly, you do it the other way around, right? So that's all you're doing if you happen to implement it in a linked list. Again, if you're using like a vector or whatever, what I did, just calling, it's at position 3 now. And so just calling remove, sorry about my writing, remove 3 does the same stuff, right? So that's my add and remove operation. And you're just going to go through the list, right? So the list is small for the test input. You're going to rn add 1, cm minus, qp add 3. QP minus will remove this one here. There wasn't much to it. Obviously, the actual input is much larger, right? So there's a whole bunch of input on this one, a whole bunch of different values that you're adding and removing. Some people on Reddit, after I solved it, I went and looked, had some cool visualizations of this. So you can look at their visualizations, right? Remember, there's only 256 boxes, so the lists kind of shrink and grow, but it's kind of fun to look at them visualized. Again, though, you're just doing simple hash map algorithms. But how do you actually solve the problem is like, well, once you have your hash map, you now need to calculate like the total focusing power. And it just gives you a function for doing that. It says for each lens, it's a multiplication of 1 plus the box number it's in, the slot number it's in, starting from 1, and then its focal length, right? So it gives you an example here, like at this in solution, it's box 0, so 0 plus 1 is 1, and then it's in the first position. Rn is in the first position, and its focal length is 1, so it's 1 times 1 times 1. So Rn's focusing power is 1, and then it wants you to do that for each of the lenses and sum them up. So what does that look like in code? Again, I just have a focusing power function on my boxes struct, and I say, hey, for each of the boxes, iterate and enumerate over them, and within each box, iterate over each of the slots in the box, right? So this will give me, I'm using a vector, right? It's going to go through each of the vector values. And then I can just increase my power by the box number plus 1, the slot plus 1, and the focal length, multiplying those 3 values together to get my focusing power. This part, again, not really a hard problem. I think in my mind, again, the way that the problem was designed was, do you know about hash maps? And I'm going to step you through kind of how to implement one yourself. And the only gotchas were, at least in my mind, is Potentially you were using a language that might not like the overflow. Again, because you're doing modulus 256, that's probably not even an issue. But something like Rust would definitely not be happy with this, so make sure you're using a big enough size to deal with the hashing. But then the rest of it's just how do you implement a hash map, and it did a pretty good job of stepping through how you might implement a hash map, with the caveat is like the add and removes are working particular for this case as opposed to like a more general case. But I didn't think the problem was overall very hard. It was fun to implement. It was fun to reminisce on. I think I was using Lisp at the time. That's how long it's been since I've been in college, people. But the idea was it's kind of fun to remember, like, oh, how do I implement a hash map? And again, this is not a true to form. You could modify this to be an actual real life hash map. Why would you do that? Most languages already include hash maps, but just for fun and giggles, maybe you'd want to modify that. But again, I think that's kind of what the problem was trying to get at, is just like, hey, do you remember this data structure that you created 20 plus years ago? Or do you know that hash map that you use without really thinking about in most of your other problems? Let's try and implement one right now and see if you can do it. And so it was fun. And so I would say, if you've never implemented a hash map yourself, or you don't understand how they work, this is a great problem, because it essentially steps you through the process of creating your own hash map, right? Maybe you're not familiar with how to use linked lists and stuff like that. Some languages have linked lists, some don't. Some you can create relatively easy a linked list, right? And so learning about that might be fun for you. Some languages like Rust, because of the ownership things, can really struggle to do linked lists and things like that. You need to know a lot more Rust to get a linked list to work than you would if you were implementing it in, say, like C or Go or Python or something like that. So I had a lot of fun. It was a kind of a reminiscing thing. I hope you had fun doing it too. Again, I've always been a fan of Advent of Code, because I think the problems they ask are wide and varied, and they allow you to like think about various different fields in the programming computer science realm. You don't always know the answer to the problem, and so you have to do some research and looking, right? But it's always a fun way for you to just like, you're at the end of the year, can I think about these cool computer science things and solve some problems? So that's what this was. You can see I actually had some tests that I wanted to verify these values as I was doing it. But there you go. So again, I'll post my answers on Reddit if you want. I'd love to see what your answers were to the problem. You can reply to me there, or you can message me privately with your solution. I just love to see how you did it. My goal is just to be positive and give positive feedback. So, I love doing pair programming and, review requests and stuff like that, besides doing my own programming. So happy to do it for you guys as well. And I think that's it. So we will see you for tomorrow.